Hello everyone, so today we're going to talk about electrolytic capacitors. So before we talk about electrolytic capacitors, we need to understand how capacitors work. And so I have made a video on this called What Are Capacitors? And I have a link in the description below. And so a capacitor is basically an electrical component in a circuit that can store charge. And a capacitor usually consists of two metal plates separated by an insulator. And so back to our electrolytic capacitors. What are electrolytic capacitors? Well, electrolytic capacitors are a type of capacitor with a very high capacitance, or can store a lot of charge. And so we have three major types of capacitors. We have aluminum electrolytic capacitors, we have tantalum electrolytic capacitors, and we have niobium electrolytic capacitors. And so can you guess what is common with all three of these metals? Well, if you have left iron outside, when it starts to rust or form an oxide layer. And what does this rust do to the nail? Well, it corrodes the nail. And so what these three metals have in common is that they will actually benefit or be protected from further corrosion from their oxide layer or rust, unlike most metals like iron or steel. Fun fact time! The fun fact is, the first electrolytic capacitor was invented in 1857 by the German physicist Johann Heinrich Buff. And so in an electrolytic capacitor, we have two plates separated by an electrolyte. Now you might be saying, what is an electrolyte? Well, an electrolyte is a substance that when dissolved in water will conduct electricity. And so let's say we have a cup and we pour water into the cup. And now let's put two wires. Let's say this wire is connected to the negative terminal of a battery, and this wire is connected to the positive terminal of the battery. And so now let's start the battery, and so we pump in electrons from the battery. But the problem is, since pure water is not a really good pure H2O is not a really good conductor, and so it won't be able to transmit the charge. And now you might have heard that water is a good conductor, and the reason for that is that when we are usually talking about water, there was some type of electrolyte in that. And so if you mix an electrolyte in this water, it will become conductive. And one type of electrolyte is salt. If you put salt in the water, it will conduct the electricity. And so the electricity will be able to go across. And so let's see how. And so if we dive in, we'll see that the individual salt molecules basically are made up of sodium, positive sodium, and negative chlorine. And in the water molecules, H2O, we have negative oxygen and we have positive hydrogen. And so this water molecule is going to act as a magnet. And so let's say the chlorine is purple, sodium is dark green. And so the sodium, which is positive, is going to go next to the negative oxygen. It will want to get to the negative oxygen, while the chlorine, negative, is negative, so it goes to the positive hydrogen. And so now that we have separated the ions, the negative positive ion and the negative ion, now we can conduct electricity. The positive sodium is going to go to the negative wire or connected to the anode, and the negative chlorine will do the opposite. And so now the sodium is going to take in electrons, since it really wants electrons, while the chlorine is going to do the opposite, give away electrons, which are going to go to the cathode. And so when the sodium keeps on taking electrons from the anode wire, it's going to start oxidizing it. And basically, when you take away electrons from a substance, it starts to oxidize. And so you're going to form an oxide layer, or like rust. So in our electrolytic capacitor, you're going to have an insulator. These plates are going to be separated by an insulator. And this insulator is going to be the oxide layer. And so this oxide layer is not going to allow electrons to pass through. But what is remarkable is that this oxide layer is going to be atomic level thin. It's going to be really thin. And when the insulator is that thin, the distance between the two plates is going to be very small. And as we saw in my other video, distance is inversely proportional to capacitance. And so when we have a low distance, we have a high capacitance. And so in this capacitor, we're going to have a high capacitance. So now let's talk about some applications of electrolytic capacitors. So one example could be when you have, let's say your computer is plugged into a power station, and so in many times there's small blackouts in the power station, and it'll be like just 2-second blackouts. And so during these blackouts, you're going to have your capacitor, which is going to store the energy during the time the power station is not in blackout, and then when it is in, the capacitor is going to be able to discharge and give you more power, and so you're not going to even notice the small power disruption. You're not going to even notice it, since the capacitor will start discharging and then the power will come back. So thank you for watching. I hope you enjoyed this video, and as always, watch these 2 videos here on what are capacitors and alternating current, and subscribe to Kids Teach Kids, and stay tuned. Bye!